Thank you very much. So my name is Ole Troan. I'm working for Cisco, but I really have my IPV6 hat on today. So I've been working with IPv6 since 1998, and I feel like a baby compared to some of the people on this panel. And I must say I'm very humbled and very honored by having this set of people on this panel and being allowed to share this. I'm not sure if you're aware of what luminaries we have here. And this is a once-in-a-lifetime opportunity, I think. We managed to drag some of them out of retirement. And if we're behaving very well and being supportive, perhaps we can keep him out of retirement, but we'll see how that goes. So we're just going to do initially go through who the panelists are. We're starting off with a history lesson where the old guys, or the old farts that some people tend to refer to them, or the graybeards, are going to give us. That's going to be very interesting, showing the rationale of IPv6, where it all came from. And then we're really opening it up for questions. We have the deployers sitting on the far side of the stage, who have lots of questions on the designers, mainly going along the lines of what were you thinking? Or we also have a poll or a survey. We asked people to pose questions to us beforehand, and the last question I got was, what were you smoking when you designed IPv6? And we'll see if we get an answer to that.
Thanks, Rob. So maybe before I do that, I understand that Vint Cerf has been going around taking blame for IPv4 addresses being too short. So I guess this is us up here taking blame for the mistakes in IPv6. So just to make sure that's...
And one of the things one of the drivers here was that not having a plan for what to do follow on with V4 was a real issue, because it looked like, you could start to see that the address space wasn't big enough, and there needed to be a follow-on plan. Whether, what happened with that was maybe less important, but these were real issues at the time. It's a very different world now, where we sort of, it's hard to remember what all these other things used to be. And we take it for granted now, but at that time it was very different. So let me do a little bit of timeline here. This is largely the ITF. So in around 1990, we could start to see the internet was growing exponentially, and it looked like we were particularly running out of Class B addresses, but overall we could sort of see this was going to be a problem. There was a group called the Road Group, Routing and Addressing, and the outcome of this was a recommendation to implement CIDR, which has really helped with the route scaling problem in the internet, and that we needed to develop a new version of IP, called IPNG.
Anyway, at this conference in Kobe, where Bob and I were, there was a session in which there were presentations on tuba and pip. And I sort of went along to that and thought, oh, cool, I'm sure Paul has done something really interesting. I'm interested in seeing what it was, and because I had some ideas too about what the next version of IP should be. And I looked at that and watched his presentation. I went, oh dear, that's not what I had in mind anyway. So on the flight back, Bob and I sat beside each other, and I railed about this and said, no, we could really just stick with IP, make it a little simpler, and there we go. So I proposed, so I was sort of the last candidate there in something called SIP, which stood for Simple IP. It wasn't Steve's IP, so everybody thought PIP was Paul's IP and SIP was Steve's IP, but no, that's not true. And the first version of SIP was basically double the address size to 64 bits. And also, we had learned a lot about, in the last 2 decades of IPv4 up to that point, we had learned lessons like that doing fragmentation at the IP layer is a mistake. Because TCP generates a big packet, sends it into the network, it gets broken into fragments, and somewhere along the line, one of the fragments gets lost. All the rest of the fragments continue to the end, consuming bandwidth. They sit in the buffer waiting for some timeout to go. A retransmission request goes back, and all of the same fragments get sent again. So the unit of retransmission was not the same as the unit of loss, and so very inefficient. And so we'd learned that lesson. At the same time, these ATM guys came along, and they had not learned this lesson. They were chopping packets into 50 or 48 byte chunks or whatever. Anyway, 48 payload, I think. Anyway, so my idea was we could actually strip. We've learned that there's pieces of IP that we don't need anymore. We don't need to have a checksum because we're already doing checksumming at the layer 2 and layer 4. What do we need 3 layers of checksum for? So why don't we take this opportunity? If we're going to have to go in and touch all the IP stacks, why don't we simplify things and throw some stuff away? So the original SIP proposal was actually only had 5 fields in the header. So there were the 2 addresses, the length, the hop limit, and the next protocol type. And it was 20 bytes long. And so that's the same size as IPv4, but the addresses were twice as big. And so that was the first version of SIP. Anyway, yeah, which I still think is the best design ever. But being a standards body, we had to compromise.
And then an interesting thing happened around 1992. The Internet Architecture Board, which at that time was actually responsible for the creation of standards in the IETF, they had to actually ratify anything that a working group or the IESG approved, they issued a sort of, I guess I can call it a proclamation, that CLNP was going to be the IP version 7. Why they picked 7, I'm not quite sure. This came to be known as the Kobe incident because they just sort of did this. There was no consensus building around this idea. It was just that, well, there was this other protocol. It was a standard from a different group. And there was a large rejection of this idea in the Internet community. And we call it the Kobe incident now because they had a meeting there was an IAB meeting in Kobe. What became the IETF community rejected this. It changed the way the IETF was structured, and that the standards authority was moved to the IESG, and the IAB, the Architecture Board, moved into a role of just making architectural recommendations. Sometimes it's never really recovered from that. One side issue is that Steve and I were both in Kobe at the same time, and this was I think after an INET meeting, and I was invited, or Phil Gross, who was the IETF chair, invited me to come to the IAB meeting. And so I went to the first day, and then the second day I asked Lyman Chapin, who was the chair, is like, should I come to the second day? Is there anything important going to happen? And he said, oh no, we're not doing anything important. So Steve and I went to Kyoto the next day and saw all the sites, while the IAB decided to make this saying that we're going to use CLNP. So it was sort of, he clearly didn't want me in the room. So the result of this was, the IETF, the IESG took this over, and a formal issue for IPNG protocols was made. The IESG took on responsibility in 1993. There was an area formed. There was a formal solicitation which laid out requirements. And then in 94, there was actually a recommendation for IPNG.
Our experience looking at what the addressing plans that the OSI community had come up with, they had specified this maximum of 20, and then they went out and designed plans that were exactly 20 bytes long. So the nature was to basically, provide lots of extra space in these addresses. And so I don't think we could have sort of kept short addresses very long, that the nature would be to just consume them and make them longer. And anyway, being a standards body, in the end we compromised, and we ended up with a fixed length 128-bit address. So not quite as long as the OSI ones. Maybe some benefits from a fixed length. And I was able to come to terms with that, partly because there had been good work on header compression, at that time. So those links on which the header overhead would be significant, maybe not so bad. And in fact, because of the fields we eliminated from the IP header, like fragmentation and so on, it turns out the IPv6 header could be compressed down to 0 bytes. So regardless of what the address size was. So, okay, I can live with that.
So I think that, it really is looking like V6 is being deployed now. This is a big change from like 4 or 5 years ago, when the allocation rates weren't that high, and there was just a lot more skepticism. I think, there's been a big change. I mean, the fact that we have people from Google and Comcast and Facebook up here is essentially, sort of, if the major content providers provide V6 access and the home network users get V6 access, all of a sudden we're going to see that the amount of traffic that's carried on V6 go up very quickly. So I'm very encouraged by this broadening community. We still have a lot of work to do.